here he asked you about the mass for a certain area. Each one of these problems had 15 marks. Remark that the line integral didn't bring any problems on line integral on the midterm or on the classworks, but you may find it on the final exam, so you will have to review it. First of all, we have x equal y squared, so it's just a simple parabola that's symmetric about the x-axis. So this is the x-axis and this is the symmetric curve. I have the line y equal x, y plus x equal 2, which is simply y equal 2 minus x. Once you graph it, it's going to be like this. This is the part that we want to find the area in between these two curves. I believe it's really very easy to go first for the x direction. So I will integrate using dx, dy. The x function for the first curve, it's really very simple, which is y squared. The x for the second function, which is 2 minus y, I will start integrating in the y direction from these 2 points. So I need to find the values of y here about the intersection between these two curves, that I will have to solve these two questions, two functions together. So 2 minus y equal y squared, you will end up having y at negative 2 and y at positive 1, and the area will be 4.5. Second, the problem, exactly in a similar manner, x equal y squared and y equal to x. This is y equal to x. This is the part that we want to evaluate. He is asking you about the mass, so instead of I will go to the, actually it will make no difference if you go for y and then for x, or you go for x then for y, it will make no difference. I will choose to take dx dy, but remember here that the density is rho v is rho t times the double integration. So all you have to do is to replace your rho by x y squared, and plenty of students that make this mistake. They didn't make this substitution, so they didn't have the right solution, but it's really very simple and direct. Once more, if you have problems in this part, you should review the lectures related to the double integration and the line integral. It's really very important. Here is asking you about how to treat an ordinary differential equation or differential equation using Euler. You will have to review Euler and to review also Roncotta. Most of you got the results excellent. All I have to do is to write the iterative equation, which is yn plus 1 equal yn plus hy dash of n. Y dash, it has to be y dash only. So if you have numbers multiplied by y dash, try to isolate y dash on one side and the rest of the problem to the other side. I will make a substitution. So this is mainly the iterative equation. I've dedicated 5 marks for this part only because it's the vital part in this problem. Then construct your table starting from the condition that's given to you in the value of y equal to 0.5 once x equal to 0. So this is x equal to 0, the value is going to be 0.5. I will take these two values, substituting here in the iterative equation, replacing x by 0, replacing y by 0.5, then y equal 0.5, you will end up having y equal 0.525. Then I will start taking 0.5 to 25 and 0.1, and I will insert them in x and y n, getting the new points and so on. Most of you got this correctly. Please study Roncotta. It's a probable method to be covered in the final exam. This problem is direct. He's asking you to check if new xy equal xi, y minus 3x, where xi is an arbitrary function, if it is solution or no for such an equation, and it's very, very simple. I've tried to get partial new partial x, partial new partial y, and make the substitution here. Once you start substituting, it's really equal to 0. I've dedicated 5 marks for this part. The other part is direct and it's already in your lecture. Just go through it and write the expansion. Most of you also get this right. The last question is about solution of a partial differential equation, and hold on. This problem, okay, I have partial theta, partial x, partial y equal x squared times y, and he's asking you to use successive integration method. is giving you the conditions. It's a straightforward problem. I will have to choose which side I'm going to integrate to. I've choose to integrate first with respect, as you see, with respect to y, then I've ended up with integrating with respect to x. Once you start integrating with respect to y, don't forget to add a function on the other variable, which is the x-axis, then integrating once more with respect to x, and don't forget to add another function which is in y. This is your general solution, so once you reach this point, you will be graded a very good mark. Then start applying the condition, either initial or boundary condition. You will have your final answer, and most of you got this problem also correct till the end of it. Minor steps, minor errors, I'm sorry, here and there about these substitutions. This mainly was about phase test 2 and phase test 1, completely in front of you. I've sent the PDF also for you on Canvas and with the student trips. Please remark, I need you to study the successive integration. I'm sorry, the separation of variables. You have the separation of variables. It's really a very probable, there will be a probable problem about separation of variables, so please do study it well. Also, don't forget the part which contains statistics and probability, various definitions, the main definitions in statistics, what's statistics, what the importance, sampling techniques, how to display your data, then the various measures, mean, mode, medians, the dispersion measures, the variance, the standard deviation, the coefficient of variation as a relative measure. Also, we did go through the part of probability that's dealing with various discrete distributions or continuous distributions. So please go through them, and hopefully all of our course ILOs have been covered with this quick revision. Please go through the lectures. You have everything you need. Study well, and with my best wishes for you all, Happy New Year, and I wish to see you in all times. And please, if you have any questions or inquiries, do not hesitate to come to me. I'm here in the university for you at any time in my office hours, and also feel free to send me any emails or something on Canvas if you have further problems or you need a quick answer for any question that will pop up with you while you are studying. Do not hesitate to send me on Teams or on Canvas. Thank you. Enjoy it. I hope you the best of luck. Thank you very much. Bye-bye.